Hey everyone, this video is a continuation from last time's FTC trajectory path planner using pose estimation video, where I talked about the benefits of using pose estimation in your autonomous routines and introduced you to the FTC robot controller library for your own use. Today, I will be going over all the different places in the code that you need to tune to refine your own autonomous paths, either with or without a USB or Limelight camera. If you want to follow on with me, you can download the library from the link below. Alright, so I'm inside the team code of the repository, which is called the FTC Robot Controller 2024. And I have a sample autonomous op mode here called auto op mode mechanism pathplan.java. And if you look inside the init drive wheels method, you will find the drive-based motor initialization. So here you want to make sure that all your motors are named properly and initialized accordingly with the motor types. So these motor types are RPM 312. And all these motor types are taken from the FTC lib library, and there's a lot of different types. So you can look over here. There's a wide range, wide variety of different types of motors. Just want to make sure that you have the correct one that you're using. So in this example, I'm going to be using the Go Build a Mechanism drivetrain, and you can set some of the wheels to inverted if they're on the left side over here. If you scroll further down, there's some PID coefficients that you want to tune for individual wheel velocity control, which is over here. And then we also have feed forward, which is also included here too. So next we want to make sure that the kinematics are updated to fit your robot's dimensions. So going down here where we initialize the mechanism drive subsystem, which should be under initialize right here. If we go into the mechanism drive subsystem, just control click in. And if we look for the mechanism drive kinematics here, you want to make sure that they fit your robot's dimensions. So over here, I set them inside my drive constants, which is over here. Over here, we have each of the four wheels, the kinematics. Here you can set things like the wheel diameters, the max velocity, and the max acceleration. And these are the specs where you can set each of these things. If you want to learn more about the kinematics and how these different values work, check out my video where I covered kinematics and odometry under FTC training. And the next thing you want to set up is the cameras. So if you're using cameras, the initialization for the cameras can be found here in the auto op mode. You just want to scroll down to where we see the cameras. It's over here. So if you want to use a USB camera, look into this method right here. The initialization should be pretty straightforward. And if you want to use a Limelight, the method is here. And really the only thing you want to change is the pipeline here. So the pipeline set here is the same one that you have set up in the Limelight dashboard. Mine is set to 0 by default for detecting April tags, but just set it to whichever one that you're using. We also have the April tags field data file. So this next step is for those who are running their robot on their own custom field layout. So if you're always running your robot on an actual FTC game field, then you don't need to worry about this next step for April tag detection. But if you are using your own map layout, meaning that you've set up an area outside of a regular field with April tags, like you have your own field set up, then you want to use a custom fmap file and put it into your Limelight. So in this April tags field data file, you can add data for all the different April tags and their orientations in your custom field. So if you look here, I have two tags right now. I have tag 42 and tag 2. So these are the two tags that I have in my custom field. But if you have your own, you just want to put in the tag ID and you can set the orientation relative to the field. And that should go into the Limelight. All right, so now we get to do the fun part, which is actually running the path. So if we go back to auto op mode mechanism, and if we go inside of initialize, we want to find our command. So in my case, my auto command is called auto 3 push command, which I've scheduled down here. So if you go into this command, this is where you're able to add each individual trajectory from your path. So here I add different trajectories, which are in pink. These are the different names of the trajectories from my path.java file. So going into my path.java file, looks like this. In the path file, I add and name every trajectory that I want along with their coordinates. So here we have two pose 2Ds. Inside the pose 2D, we have an X and a Y value along with the rotation 2D, which is theta. And we have two of these. So these represent the starting and the ending points, the starting and ending waypoints of the trajectory. But if you want, you can add more waypoints in between. Here I added a third waypoint, which is a translation 2D that I want my robot to reach in between the time it takes for it to drive from the starting position, which is this, to its final position here. So you can add as many as you want. So I just have a third here, but you can add another one. You can add a fourth, and you're free to do whatever you want with it. All right, so going back to your auto command, and with all your trajectories inside of your auto now, you want to tune the PID constants for each part of the path. So once you've gotten all of these in, all of your trajectories inside of here as mechanism controller commands, you want to tune the PIDs for each of these. Now keep in mind that this is completely separate from the previous PID tuning we did in the beginning. Those were for controlling individual wheel velocities on the drive base, and this is for controlling the robot's feedback loop for correction while it's traversing a specific path. So it's very important that you tune these, and it's an amazing feature that allows you to specifically tune an individual path inside of your larger autonomous routine in isolation with the rest. So be sure to use that to your advantage. Alright, so that pretty much covers everything you need to know when creating and tuning your own autonomous routine using pose estimation. This library is great because it allows you freedom in the way that you want to control and correct your individual paths, which means that if you're trying to hone in on or change one specific segment of your autonomous, you can mitigate the problem of having your whole autonomous routine affected by those changes. It also allows you to utilize a USB or Limelight camera if you wish for more powerful robot localization capabilities. Thank you so much for watching, and I'll see y'all next time.